Yesterday, we did two activities. First one was dealing with figuring out what the sum of the interior angles of a triangle is. And we found that that measure of it, sum of a triangle is what? So we know all the angles in a triangle add up to 180 degrees. All right, so if you don't have that filled in there, write that down. That's a big thing for this section. Hey, so we're going to do a little proof here that proves this based on stuff that we know. So we start by drawing a line here that they say is parallel to AC down here. And then in step 2 it says measure of angle 1 is congruent to what angle? So 1 is congruent to 4. And then as we look at it, they then ask about 3, which we're going to use this line now. So then 3 is going to be congruent to what angle? 5. And what's our reasoning that we know that those are congruent to each other? Good, those are alternate interior angles, so stuff from Module 4. And then as we look at it, we see that angle 4 plus angle 2 plus angle 5 gives us that angle there, which forms a straight line. And a straight line has an angle measure of 180. So we can state that 4 plus 2 plus 5 equals 180. Now, since we know that 1 is equal to 4, I can replace angle 4 with angle 1. And we know that angle 3 is equal to the measure of angle 5. So I can replace angle 5 with the measure of angle 3. And then angle 2 stays the same. So angle 1 plus angle 2 plus angle 3 equals 180. What would be our reasoning? What have we done for that step? Replace measure angle 4 with measure of angle 1. And replace measure of angle 5 with measure of angle 3. That is substitution. All right, so to reflect, I want you to discuss this in your groups, and I'll call in someone to share out. What does the triangle sum theorem indicate about the angles of a triangle that has 3 angles of equal measure? So if I have 3 angles, and they're all the same, what does the triangle sum theorem state about that? No, all 3 of them have to equal 180, because that's what the triangle sum theorem tells us. So if all 3 of them are congruent and all 3 of them equal 180, what can we say about each individual angle? Yeah, these should be all 60 degrees, right? If we have 3 angles, call them x, and they all have to add up to 180, 3x equals 180 divided by 3, and x equals 60. Now, does anyone know what that triangle is called when you have all the angles that are the same? There are 2 names you could go with. First one, if you're just strictly talking about angles, is equal angular. But the better one you'd call it is equilateral. Second project we did yesterday was coming up with what is the formula to find the sum of interior angles of any polygon. And with that, we came up with the formula n minus 2 times 180. Let's now apply that rule. So as we look at number 2 here, it says a non-agon. Non-agon means 9. If we count over here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So a nonagon is a 9-sided figure. And we want to find the unknown measure. Well, in order to find what this value is, we would need to know what they all add up to. So what could we use to figure out what the total angle measure of a nonagon is? This formula right here that tells us the sum of any polygon's interior angles. So if I go 9 for n minus 2 times 180, that gives us 7 times 180, which is now 1260 is now the total angle measure of that whole figure. So then how can we find out what that missing angle is if we know what the total is? Yeah, if we add up the known values here, right? So 135 plus 98 plus 102 plus 140 plus 200 plus 172 plus 130 plus 125. Add that all up. And then once we add that all up, we get a total, and we subtract that from 1260. So someone with the calculator. All right, so our total of all of these added together is 1102. So if I subtract that from what I know my total for the whole figure has to be, we get 158 degrees equals our missing angle of x. All right, let's look at a couple ones that are now word problems, but the same idea. So number 3 and 4 you can do on your own, but I'm going to help you out a little bit to get started. So this is determine the unknown interior angle measure of a convex octagon. So for an octagon, how many sides are there?
7.
There are 8. Octa, like octopus, there are 8. In which the measures of the 7 other angles have a sum of 940. So what would be nice to know in this problem besides the answer? The total measure of a figure that is an octagon. Okay, so I'll let you work on that. And then number 4 says determine the unknown angle measures in a hexagon. How many sides are in a hexagon?
8.
6.
I saw 8 up there.
Okay, and then it tells us 6 angle measures this time are 69, 108, 135, 204, B, and 2B. So work on those 2 problems in your group. Good. If we substitute the 8 in for our n minus 2, hey, so we have 8 minus 2 times 180. So then we get 6 times 180, which equals what? 1080. Now, what other piece of information do they give us on that problem? 940. What does that 940 equal? The other, how many angles? 7. So we don't care what each individual angle measure is. We just know that all 7 is 940. So if I want to find the 8th angle, and I know the total is 1080, and I know 7 of the 8 is 940, what are we going to do? going to subtract. So we would then take the 1080, subtract 940, and that gives us 140 for that problem.
Oh, that's what I messed up on.
Go ahead, Gia.
Okay. Well, I know about the 2B and the B, but I did the 6.
Okay, good. So we start by finding the total angle measure, which is what?
I got
720.
720.
And then what?
And then I did 720 minus.
Okay, so I'm going to write this out kind of as an equation. So we know we have 69 plus 108 plus 135 plus 204 plus B plus 2B, and that has to equal 720. If we combine all those, we get 516, and B plus 2B is 3B, and that equals 720. If we want to solve from there, as G had said, we're going to subtract that 516,
I got 204.
and you get 3B equals 204. Divide by 3, and B equals what? 68. Now, they didn't ask for just B, they asked for the missing angle measures. Well, one of those angles is just B, so that one is 68. But the other one is 2B, so I need to go 2 times 68, which is 136. All right, let's jump down to exterior angle theorem. Now, we're not going to prove it, but what I want us to understand is that the exterior angle of a triangle is equal to the sum of its measure of the remote interior angles. So essentially what that is stating is that this exterior angle here, angle 4, measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. So the two angles that are not attached to angle 4, those are going to be equal to angle 4. So my two opposite interior angles are equal to the exterior angle. So how that plays out, if we look at number 5 here, I know my exterior angle is equal to my two opposite interior angles added together. So 2z plus 5z minus 2. Then from there we would solve. So we get 145 equals 7z minus 2. Add the 2 over, and we get 147 equals 7z. Divide by 7, and z equals 21. Now, they didn't ask us for z, they asked us for the measure of angle B. So we need to substitute that value in for our z here. So we get 5 times 21 minus 2. 5 times 21 is 105, minus 2 is 103 degrees. All right, number 6. I want you to work on number 6 in your groups, and then we'll come back together and discuss it. One thing that'll help, if we go back up here to our theorem, I stated that the exterior angle. Angle 4 in this case is equal to the two opposite interior angles. So as we go to number 6, which one is our exterior angle? PRS, right? So our exterior angle is 3x minus 8. And then the exterior angle is what? What do we do with that? It's equal to our two opposite angles. So in this case, our two opposite angles are x plus 2 and 90. Combine like terms and solve. So we get 3x minus 8 equals x plus 92. Add 8. And 3x equals x plus 100. Subtract x.
And get 50.
And we get 2x equals 100. Divide by 2. And x equals 50. Now,
You're 48. Only.
do they ask us for x?
No, ask you for the angle of PRS.
Yeah, we want PRS, which means I'm going to substitute 50 in for x there.
Wait, how do you?
And you get 142.
Oh,
So the measure of PRS is 142 degrees. To finish,
Hey, that's disrespectful.
we've talked about two major things today. So I want you to summarize the rules. What do we do in order to find the interior angle sum of any polygon? You can write it out in a sentence or you can write it into the formula or equation. And then how do we find the exterior angle of a triangle? So you're going to have two statements for me, two sentences, two bullet points, two equations. I don't care how you describe it, but you're going to have two things that you're going to describe for me. Hey, so for interior of a polygon, remember we have the n minus 2 times 180. Hey, for the exterior angle of a triangle, what do we do? So for exterior of a triangle, we can write the exterior angle is equal to the two opposite interior. Or as we had written before, the measure of angle 4, which is our exterior angle, is equal to the two opposite interior angles added together.